video is going to talk about linear functions, which are special type of functions. And so linear functions are functions that have a constant rate of change. That's the definition of a linear function. And so that means that we are adding or subtracting the same number. So in this example, Juan is renting video games online. His subscription to the game website cost him a flat fee of $5 and then $2 per game. So to start, he has to pay $5 before buying any games. After one game, he's paid $7. After two games, he'll pay $9 in total because each game is going to add $2 to the cost that he has to pay. After 3 games, $2 more is $11. And after 4 games, he's going to have paid a total of $13. So the initial value for him is the $5, how much it originally cost him. Rate of change is the important vocab word for this, and that is what he's paying each time. How much is it increasing per game? And that's $2. So when we write linear functions, we use a model that may be familiar to you, mx plus b. You may have previously seen it as y equals mx plus b, but in this unit, we are using f of x. We're using function notation. And so the rate of change is the letter m. So for Juan, his rate of change was 2. So if we were going to write a function for Juan, we would say 2x. And then b is the initial value, which for Juan was 5. So we would make it plus 5. These are called parameters. So that's going to be the fancy word we use. So the parameters are rate of change and initial value. Parameters are essentially the letters that we replace inside the function. So the reason we like to have an equation is because let's say Juan is a really big gamer and he's going to rent 15 movies in a month. We can just plug now in 15 to represent the number of video games he takes out. And we can easily calculate that it's going to cost him $35 that month to rent 15 games. So having a formula or a model helps us to calculate future values without having to do the entire pattern the whole way out. So the initial value is always what matches with x equals 0. So let's actually write that over here. So this is what matches with x equaling 0. So in this table, sometimes people think like 7 is the initial value because it's the first one of the table. But it's not, because it's not what matches with 0. What matches with 0 is -2. So that's the initial value. The rate of change is how much is f of x or y changing by for every 1x. So that's important to know. How much is x going up by here? X is going up by 1. Y is going down by -3. Same thing here. Y goes down by -3. X goes up by 1. So the rate of change is -3. We're going to talk about how to calculate the rate of change on the next page, but essentially it's the change in y over the change in x. And so the function, we're going to plug in our parameters to the equation. So next to x goes the rate of change, which is -3, and then plus b, which is the initial value, which is -2. Or we could have just written -3x minus 2. Either one would be fine, plus -2 or -2. I actually prefer this one. Okay, so this was what I was talking about. In order to be linear, a function must have a constant rate of change. To calculate the rate of change, we use this little symbol, the triangle symbol. That just represents change in. We know mathematicians are lazy, so they like to come up with symbols and abbreviations for everything. So when we say a triangle y and a triangle x, we're really saying change in y over change in x. You guys actually might remember this formula, y2 minus y1 over x2 minus x1, as slope, the formula to calculate slope. Rate of change is actually the slope. So if you remember that vocab word from last year, you are correct. So to decide if something's linear, we want to make sure it's adding or subtracting the same number every time. So if we look at this table, y increases by 4, x increases by 2. So to calculate the slope, we have to do change in y, which is 4, divided by change in x, which is 2. 4 divided by 2 is 2. So the rate of change between the first two sets of points is 2. All right, let's check out the next one. From 7 to 9, y increased by 2. So at first your brain might be saying, I don't think this is linear because these two numbers are different. But if we look at x only went up by 1. So the rate of change here is 2 divided by 1, which is 2. So actually, so far, this is linear. Let's check the last one. 9 to 21 went up by 12. 7 to 10 went up by 3. If we calculate the rate of change, 12 divided by 3, the change in y divided by the change in x, that's 4. So this is not linear because the rate of change, which I like to abbreviate as ROC, isn't constant. So it was at first 2 and 2, but then when I calculated it to be 4, that kind of messed it up. Let's check the next table. Y goes down by 3, x goes up by 3, so the rate of change, -3 divided by 3, is -1. -11 to -12 goes down by 1, goes up by 1 for the x. So the rate of change is -1 over 1, which is -1. And then from -12 to -14, I went down by 2, x went up by 3. So at first it was linear, but at the end it changed to -2/3. So same reasoning. It's not linear because the rate of change isn't constant. Okay, so that's how to decide if it is linear, by checking the rate of change, by calculating it. When you're giving something that is linear, and in order to make this linear, this can't be 21, this needs to be 15. So let's calculate the rate of change. Y went up by 4, x went up by 2. So the rate of change is 4 divided by 2, which is 2. Let's just check it for the rest of the table. 2 and 1, 2 divided by 1 is 2, and then this is why I had to change it. 9 to 15 is 6, 7 to 10 is 3, 6 divided by 3 is 2. Okay, so that's how to calculate the rate of change. Finding the initial value is a little bit different because I don't have x equal to 0 here, like I did on the last page. I want to know when x equals 0, what is the y value? That's what I need to calculate right now. So here's the steps to finding it. I'm going to take the equation f of x equals mx plus b. And I'm going to plug in what I know. I know m is 2. And from my table, I actually know a bunch of x and f of x values. So I'm going to pick 1 point from the table. I could pick any of them. I'm just going to pick 4 and 3. 4 is the x value. So in this equation, I'm going to plug in 4. The f of x value, so the whole thing here, is 3. So 4 was x, 3 was f of x. So I'm going to replace that on this side. So my equation that I get is 3 equals 2 times 4. The whole reason I'm doing this is to solve mathematically for b. So 3 equals 2 times 8 plus b. So if I solve for b, I get that b has to be -5. So now I know my 2 parameters. I know m and I know b. So any linear model is f of x equals mx plus b. In this case, m is 2, b is -5, so my function is 2x minus 5. Here's how you can check to make sure that you did that right. Pick another set of points in the table. I'm going to pick 10 and 15. When I plug 10 in for x to this equation, I should get out 15. So let's see. If I do f of 10, if I plug 10 in for x, 2 times 10 minus 5 is 20 minus 5, which is 15. If I were to get anything other than 15, that would tell me that my equation was not accurate. But since 10 and 15 are matched up, I know I did it correctly. All right, let's calculate our rate of change here. So y went down by 3, x went up by 3. So my rate of change is -3 divided by 3, which is -1. To find the initial value, I'm going to pick one of my points from the table. And last time I picked the first one, I'm just going to pick this one this time. Doesn't matter which one you pick. -1 is going to go in for m. 3 is the x value, so I'm going to plug that in for x. 5 is the y value, so I'm going to plug that in, or the f of x value. I'm going to replace f of x with that. So I can do 5 equals -1 times 3 plus b. And so if I solve for b, if I get b alone, I get 8. So now I have my 2 parameters. So it's going to be -1, or just -x. You don't have to write the 1, plus 8. That's going to be my function rule. So let's pick a random point to make sure that that's correct. Let's plug in -2 for x. If I plug in -2, -2 plus 8 is going to give me out 10. So I know that I did this correctly because plugging in -2 gave me -10.